Alright, so you now know what vanishing gradients are, and let's now take a look at what exploding gradients are. I can tell you exploding gradients have nothing to do with the sigmoid. They have something to do with the weights. And again, you have to think in the pre-millennium period when sigmoids were used for activation. So here is the same network, the same update rule, and the same chain rule. Yeah. So here is actually, that should be W1 old. Yeah. And here as well, it should be old to be absolutely correct. So what we're gonna do now is, so here you have an input. Yeah. And here you have an output. That is the input for the second node, so we call this one, let's call this one Z2, and let's call this one Z3. Yeah, Z3 is the output of this node and is the input of the next node. So all of these have also biases, B1, B2, B3. Okay. Okay, so let's now take this term here. Yeah, we have A3 with respect to A2. Yeah, I would like to get Z3 in there. Yeah, so we have A2 times W3 plus B3. This one is Z3. Yeah. That's what the input is going to the activation A2. So now here I can use the chain rule, and the A3 with respect to A2 is the same as A3 with respect to Z3, because A3 will be a function of Z3 because Z3 is the input, and then I have the derivative of Z3 with respect to A2. Yeah? This is simple chain rule. Yeah. Now, the activation with respect to Z3 is sigmoid. Yeah. So this is a number between 0 and 0.25. And the Z3 with respect to A2, this is DZ3. This is this disappears, and the outcome is W3. Yeah. So here is your risk for exploding gradient, because W3 could be, 500. And you just initialize randomly. And imagine that you go deeper, then this 500 is multiplied with bigger numbers and your gradient will explode. Yeah. So basically what this says is that initializing your weights is important. Yeah, that is basically what exploding gradient is. Alright, so now we know what these two are. Let's take a look at what ResNet is and how we will use it in our coding exercise.